Now see the next one. A cradle of is h meters above the ground at the lowest point, and capital H meters when it is at the highest point. If v is the maximum speed of the swing of total mass m, the relation between small h and capital H. Just imagine. So then whenever you are swinging on the cradle, so you have to apply this logic. Work-Energy Theorem you have to apply, recollect it. So tell me now what they're saying here. So here, yeah, this is the cradle. Now just imagine now here, and here this is the ground. You see the ground, and this is the lowest point of the cradle. So when it is at the lowest point, this height is given as small h. And when it is swinging, so when it will goes to here, let us say highest point, when the cradle is somewhere here. So here, when the cradle is here somewhere like this, when it is here, this is, let us say here, this is the highest point of the cradle. So that means now this height they given as a capital H. This height which will be a capital H. Isn't it? Now, and so then if v is the maximum speed of the swing of the total mass, they are asking to find the relation between small h and capital H. Yes. Now you tell me now here. Here. We need to find the total work done. Right. Work done, yeah. So work done, work-energy theorem we have to apply now by using work done analysis. Tell me now here. So this is work done. Work done by the gravitational force plus work done by the normal reaction plus work done by the applied force plus work done by the frictional force plus work done by the spring force equal to delta Ke. So you tell me now here in this case the forces, let's talk now here. Gravitational force is there. So now gravitational force, now look at now we have taken this ground is a reference we used to take now. Ground is a reference now here. Now tell me the work done by the gravitational force when it is here. So you tell me now here how much the height has been traveled here from here to here to net height we have to see now. That is how much now. So yeah, when it is here, this is on the surface now here. This is on the cradle. It is moving to here. That means this effective height is how much now? Capital H minus small h now. And then the gravity is downward direction, but the displacement is upward direction. So that means work done by the gravity is minus mg into what, tell me now? Capital H minus small h. Though normal reaction work done 0, applied force work done 0, frictional force and spring force, which is equal to change in kinetic energy na? So that means initially at rest only. Yes, now final kinetic energy we have now. That is what, tell me now here? Yes, yes. Now in this case, at this location, how much the, what we can say, kinetic energy here? At the highest point, what is the velocity? 0. And the lowest point only we have high velocity. Isn't it? Why? Because it is going there, again will fall because the velocity is 0. Then final velocity is how much? 0. Initial velocity we have something na. That is of m into u square. Now, so minus will get cancelled. So that is mg into capital H. Okay. Minus mg into small h, which is equal to half m into u square. Na? M will get cancelled.
Plus mg into small h will come. Minus
Yeah, this minus cancelled. Here this minus, left and right minus is there now. Right. So that means small m will get cancelled here. So we'll come it as what tell me now here? G, we can say now 2gh. Okay, 2gh, which is equal to, so here gh plus what tell me now? V square. U square. U square by 2 na. Why 2 came? Yeah, that 2 will come here also. Now fine, now we need to do capital H. Options are given the capital H. Now capital H is equal to H plus, we can say now U square by 2G. Divide with the 2G both sides.